Okay, welcome to this lesson on trying to find coordinates of stationary points, and we want to determine them. So in this case, we have two methods here, which is the first derivative or the second derivative test. So maybe the very first thing is at all the clues that we have is at stationary points. We know that the differentiation of the curve in this case, which will be the gradient dy dx, is equals to 0, right? It's either a maximum point, minimum point, or a point of inflection. So the first step we have to do is to differentiate. So we're going to differentiate this guy, right, which is x to the power 4 minus 4x cubed plus 2. So we have 4x to the power 3 minus 12x squared, and that's our differentiated form. So at stationary point, okay, we know that dy dx is equals to 0. Okay, why dy dx equals 0? Because minimum maximum points, they all have gradients where we can say that tangents there, right, have gradients equals to 0. So dy dx, which is the gradient at that point, will be equals to 0. And from here, we substitute back 4x cubed minus 12x squared equals 0. Factorize out 4x squared, we will get x minus 3 equals 0. So from here, we can easily tell x squared equals to 0 or x minus 3 equals to 0, which gives us two answers. This means there are 2 points, x equals to 0 or x equals to 3. So at these 2 points, x equals to 0 and x equals to 3, they are stationary points, but we need to determine what kind of roots, right? So we're going to use the first derivative test, or probably the second derivative test, right? Let's use the first one first, right? Or maybe you can use second. I prefer second because second is actually much easier. So the second derivative test over here is to differentiate one more time. So you'll get 12x squared minus 24x, right? So you're going to say at x equals to 0, x equals 3 first. Okay, we'll do the first one, x equals 3, d2y over dx squared. You sub in the x coordinates, which is 3 squared minus 24 times 3. This will give you 12 times 9 minus 72, which is actually 108 minus 72. Okay, you can actually use a calculator, it will be much faster. So this value is a positive value, since d2y over dx squared is more than 0. We want to find the coordinates, right? So when we sub x equals to 3, okay, we want to also find y, right? So what's y? Y is the y coordinate of the point. So we're gonna say y is equals to 3 to the power 4 minus 4 times 3 to the power 3 plus 2. Wow, it's a very big number. So this 81 minus 4 times 27 plus 2. So this 81 minus 108 again plus 2 is 83 minus 108. So 17 plus 8, 20, negative 25. Okay, so we can say 3 negative 5 is in this case, a minimum point. Okay, now at x equals to 0, we somehow find that d2y over dx squared is equals to 0. Hence, we cannot really conclude that we can conclude here that the stationary point at that value of x is a point of inflection, right? So we can say quickly, since d2y over dx squared is equals to 0, this point, which will be 0, you sub in x equals to 0 into the equation, you will get 2, right? Is a point of inflection. Okay, so that's a point of inflection. So how does it look like? So if you want to figure out how it looks like, you need to use the first derivative test. So using the first derivative test, which means you have to come up with a kind of like a table. Okay, but I know it's not required of this question, but it's actually good to know how it looks like, because when you know how it looks like, you can also practice a little bit, right? So what I'll do is when x equals 0, I will choose a value on the left, which is -1. I'm going to choose a value 1. So I'm going to figure out what's the how it does it look like. So at x equals to -1, I will have at the dy dx, you just need to sub it inside there. The first one is -4. -4 minus 12, you will get a negative value. So I'm going to the shape of the gradient on the left of 0 is actually going down. Okay, when x equals to 1, it will also be a negative. So it's actually a point. This is a point of inflection going downwards. So if let's say I were to draw this part of the curve, which is not required here, but it's good to know. And so 0, 2 is somewhere here. Okay, it will be a point of inflection going down. Right, so something like that. Okay, but because it's not required of this curve, of this question to draw the curve, so we don't have to go to the extent to use first derivative. So that's all for work example 10. Okay, see ya.